Good evening. Welcome to our TI Technology webinar hosted by Texas Instruments. This will be the second in the series, How To with your TI-Nspire CX. If you weren't able to view part 1, I'll be sending out a link to that later in the webinar, in case you're interested. It is also found on the education.ti.com website. My name is Ruth Casey. I'll be the moderator for the event. We'll be using the WebEx chat features tonight. We'll use this for sharing comments or asking questions throughout the webinar. When you have a question for Judy or want to share some comments and you use the chat window, please choose everyone from the drop-down menu. If you choose one of the other selections, it's not guaranteed that Judy would be able to see it. So choose everyone. Let's try it now. We invite you to select everyone and share your location. Give a greeting.
Ruth, I'm not seeing the next slide.
All right.
I saw the first one. Maybe it's me.
Well, I think I'm sharing a slide, and right now it has your picture on it, Judy.
Okay.
So I'm hoping that we're sharing that slide. If not, we'll just pass it on to you and we'll get started. Okay.
I don't know why I'm not seeing it. So
All right. Well, I'll try again.
again, it could be me.
Okay. Well, Judy, while I'm getting the slides up, go ahead and tell us a little bit about yourself.
Okay, my name is Judy Hicks, and I am a math educator from Colorado. I have been using TI products for many, many years in my classroom and working with teachers, and just happy to be here tonight.
Thanks, Judy. If the slides don't show up now, then I'll just do a bit of reading aloud and we'll get back to them a little bit later.
We're good.
Okay.
We're good.
All righty. Just had to, unplug it and plug it back in.
All right, so for the agenda tonight, we're going to do a little bit of a warm up to make you start to put your thinking caps on. Last time we didn't have time to do the geometry app, and I just wouldn't feel right if we didn't do a little bit with it. And then hopefully we'll do some list and spreadsheet and some statistics, as well as doing things with images. And I'll be using the premium software through the night.
And at the close of the webinar tonight, we'll have a bit of time for question and answer. But remember, you can send those questions in via the chat throughout the session. We'll have a webinar drawing. Some lucky viewer will win complimentary registration to the T-Cubed International Conference. The virtual conference will be held in July. And we'll also send out a link for certificate of registration, certificate of attendance.
Okay, as Judy just said, the outcomes for the night are going to be using geometry a little bit, list and spreadsheet, as well as the software and images. All right. Thanks, Ruth. So give me just a second to share my screen.
A reminder, and I don't know if I said this to get started, this is being recorded. So if you have any audio or video issues tonight that can't be resolved, just catch the recording later. If there's something going on and you just want to watch Judy and tune in later with your own device and try what she's doing, again, it'll be recorded. You can find it on the education.ti.com website about webinars. You'll also be getting an email with information about the recording, a link to the documents, and your certificate of attendance.
Okay, hopefully you're seeing my screen. And what I'd like to do is just to kind of get people thinking about geometry. Now, I don't want you to use your calculator or the software or anything. This is just either in your head or on a piece of paper. So I want you to draw a circle with its center point and radius. And then I want you to think of two different methods to find the diameter. And just as a hint, you can draw, you can think construction, or whatever. Now, when you do your two different methods, you can send them at once or separately. So I'm going to give you about a minute to think about that. Okay, we're starting to get a few things in. Try to think of two different ways. And they don't have to be, wowie zowie ways. Now, one thing, and I probably should have made this clear, is this is an arbitrary circle. So I really don't know what the value of the radius is. Thank you for all the chats coming in. That's great. Keep them coming. We're not going to spend too much more time, but I just wanted you to kind of start to think about geometry. Now, I could spend the next 2 or 3 hours on the geometry app with Nspire, but again, I'm going to try to limit myself. And you can either follow along with me, or you can, as we said, you can go back and look at the recording later. So the first thing I want us to do is kind of to piggyback this idea. So either watching or on your handheld, we're going to either start a new document. Again, if you're on your handheld, I can press the home key, go to number 1, and we're going to add a geometry page. Now, again, the geometry app, if I press the menu, you can see just a ton of stuff here, which we are not going to get into tonight, but let's just do a simple thing. So we're going to go to shapes, we're going to do a circle, and I just drag it out. And this is kind of what I asked you to do. Now, I also asked you to put in the radius. So let's go ahead and do that. I'm going to press menu, and I'm going to go to points and lines and go to segment. And again, if I'm going too fast, I'm typing and talking. So hopefully that's slowing me down a little bit. But if you miss something, just yell or chat, I should say. All right, so I'm going to go from the point to the radius, or I'm sorry, to the point on the circle, and there's my radius. And if I'm not sure how to use a tool, remember I can always go up here to the tool tip and it tells me what to do. I press the escape key to get out of that. Now, in the chat, when I asked you to do this, I heard various things. Double the radius, do a chord, bisect the chord. So we could do a perpendicular bisector. Think about transformations. What could I do? In fact, put that in the chat right now. What could I do with the circle that I have using transformations to come up with the diameter? That's a question. Is there something that I could do to use reflection or, all right, reflected across the tangent line. Okay, good. So I just kind of want you to be thinking about different things that you could do. Now, when I gave this problem to my students, this is what they did. And some of you might have been thinking this, and this is fine. There's nothing wrong with this. I'm going to go to Menu, Points and Lines, and I'm going to do a line. I'm going to go from this point out to this point. Now, I purposely did it this way to point out a couple of things, because sometimes my students would say, well, what? This isn't a line. But if I go to the end of this line, I can now drag that out. So I'm holding down on my software, I'm holding down my left mouse, my left click, and now I can, there, right there is my diameter. So I'm going to press Menu, go back to Points and Lines, Segment, and now I'm going to actually put the diameter on top of this. Now I can't see it. Yes, I could change colors and all of that, but if you look at this, you can see that the segment is the diameter. Now, in middle school or perhaps even late elementary school, kids start to look at the relationship between the circumference and the diameter. So what I'm going to do, I'm going to measure both of those. So go to Menu, Measurement, and circumference, of course, is considered length. So when I go up here to my circle, and the nice thing about having your students do this, everybody's got different things. So I click on my circle, and then I'm just going to move that value out of the way. Now, yes, I could label it and make it fancier, but just for time's sake, we're not going to. Now, then I'm going to go to, now notice that as I go along here, do you see how my radius kind of darkened? Well, I want to make sure that I get my diameter, at least for me. You might be thinking 2 pi r instead, but if I go to I hit Tab to make sure I'm getting my entire diameter. So I press that and move that up here. So now I want to know, is there a relationship between the circumference and diameter? Now, of course, you know what that is as math teachers, but your students, and sometimes I would have my students go through and say, well, what happens if I add them? What happens if I subtract them? And try all of those different things. Well, we're just going to jump to the end, but we want to show it. So I'm going to go to Menu and Actions, and this is something people don't use too much, which is why I wanted to point it out again tonight. I'm going to go to Text. Now, we already know as math teachers that C, and then I'm going to go over here and say divided by, oops, not plus. Sorry. There's my divided by. And then D, we already know that that is the relationship. But again, you could have your kids. The geometry app lends itself so well to kids being able to go through and discover stuff instead of us just telling them. All right, so what I want to do is I want to show that this C over D is actually pi. Again, we're just cutting to the chase here. So the way that I'm going to do that is go to Menu, Actions, and I'm going to go to Calculate. Now, the way that Calculate works, if you haven't done it for a while, is if I click on the expression, and then what it's going to say is, all right, what do you want for C? So I go up here and I choose, in this case for me, 34.0. And then notice as soon as I clicked, it says, all right, now select D. So I'm going to go to here and select D. and I get this value of 3.1, which doesn't mean much. So if I go over to my number and I hover over it and I hit the plus sign, that looks familiar. But now, is this only the case for these two? Or what happens if I make the circle bigger and smaller? And again, there are activities on education.ti.com that you can do exactly what I'm doing here. Now, sometimes my students would say, well, these values are changing, but this one's stuck. And so sometimes we have to do some data collecting and all of that. But that's just a really simple little construction that's not too tough for the kids to do. You know, some of the constructions are a little more difficult, but this one wasn't too bad. Any comments or questions? And think about, you know, okay, put it in the chat. What grade level do you think we could do this? Tell me what you think that wouldn't be too bad for kids to do. What grade level? I don't know what section 1 means. I just saw that in the chat, but you need to tell me maybe, okay, grade 9 or 10, junior high, 10th. All right, so hearing different things. The person lower secondary, grade 7, good. So again, it's not a too tough of a construction. And boy, it's powerful because now kids can say, well, no matter, you know, the circumference and the diameter, that relationship. So again, we want to try not to just tell kids stuff. All right, so let's move on. Now, another strength that I like about the Nspire is how it can relate geometry with algebra. Because I know when I was teaching geometry, sometimes my kids just thought, you know, geometry was the course that we put in between Algebra 1 and Algebra 2 just to make them suffer. And sometimes that was true. But we want to try to tie them together as much as we can. So I'm just going to stay in the same document, and I'm going to add a graphs page. Now, another thing that I'm going to do, and depending on if you have a CX or a CX2, this can be done just a little bit. I'm also going to press my escape key to put my function line away. But for right now, I'm going to go to Menu and View, and I'm going to turn the grid on. Now we've got a dot grid or a line grid. If you happen to be using the CX2, you can do this in the settings as well. All right. Now, what I want to do is I want to relate the algebra and the geometry a little bit. So what I could do, but then I'm going to show you a different way. I could go to Menu, and of course, all of this stuff up here is about graphing. But notice that, boy, there's my geometry. So I can do what I would, you know, a lot of the stuff I want to do from here as well. So I could go to shapes. We're going to do a little bit of transformation now, and I'm going to choose a triangle. Now, just for quickness, I'm just going to, and notice that up here in the tooltip, click 3 vertex locations, but I'm just going to go click, click, and click. Now, think about the questions that we might ask students. All right, given this triangle, now we're thinking transformations. Given this triangle, what happens to it when I reflect it across the y-axis? You know, what happens to it if I reflect it across the x-axis or across some particular line? Or think besides reflection, think about all the other transformations as well. Well, I could go to here and say, show me this coordinate. So if I right-clicked on that, I could have also pressed the menu. if I go to coordinates and equations, and of course I just, those values aren't too bad. These aren't quite as nice. And I could do the same thing for the other two, of course. But now if I reflect this across this, think about the questions that you could ask kids. Are the shapes going to be congruent or similar, or, depending on which words that you've talked about in your classes? What's going to happen to the coordinates? What's going to happen? And again, think about all of the kinds of questions that you could ask kids. Now, I want you to hang on to that thought for a moment, but I did want to show you something else that sometimes people either don't know about or have forgotten about. You can only do this on the software. So you'll just have to watch me on this one, but that's the reason I wanted you to see this one first. All right, I'm going to go to menu. And I'm going to go to actions. And I'm going to go all the way down here to D, to Math Draw. Now, Math Draw is something that works really nicely if you have a touch screen, or right now I can just use my mouse. If I happen to have an interactive whiteboard, I could have kids come up and do this. But what I'm going to do, oops, I don't want to do that yet. I got a little quick on my values there, but I'm still in Math Draw. Now notice, it says I draw certain geometric objects using mouth gestures. Each object has a single gesture. So you'll, oops, I put it away, sorry. Pick that up again. And so now I'm going to hold down my left mouse and I'm going to draw, not very well. And there it is. As soon as I let my finger go, notice how, first of all, it locked into the grid points. It automatically labeled, which Math Draw does. So the kids love to come up to the board, come up to your computer, and do that again with their, I could have easily just done it with my finger. So now, once again, I can go through and I'll let you experiment with other things you can draw. There are other things you can draw besides a triangle. It's kind of fun. But once again, I can go to coordinates and equations. In the classroom, of course, I would do that for all three. But for right now, I've got my triangle. I want to reflect it across, let's say, the y-axis. So again, I'm going to go down here to geometry, transformations. And again, notice you've got all of them, but I'm just going to choose a simple one for now, reflections. And first of all, again, if you're not sure, click the line of reflection and then the object to reflect. Some transformations, the order matters, others it doesn't. So I want to reflect across the y-axis, and this is what I want to reflect. So I click, and now I'm really interested, since I showed the coordinate value of C, I would ask kids, well, what happened here? What changed? What stayed the same? And then, of course, they could go to here, show the coordinates and equations, and hopefully just from looking at it. Now, the nice thing about this is I can go back to my original one and I can start moving it around. And again, just note for time's sake, I only did one value. But I could move this around. I could pick up the whole triangle. And lots of great discoveries, and all of that can come out of this. So yes, I threw in Math Draw just because I think it's cool, but I could easily have just done everything with the menu in the geometry menu part. So anyway, I just wanted to show you Math Draw in case you haven't looked at that before. So if we think about all the, again, good things that we can do around transformations, and once again, kids start learning about transformations in elementary school and then continue up. And then, you know, in high school, they start talking, like I said, about congruency and isometries and all of those other things that start to occur. So, you know, where the vocabulary comes in is great as well. Now, one thing that I did want to talk about just a little bit is this was a quick introduction. On education.ti.com, there are lots and lots and lots of activities that, oh, I'm going to have a hard time getting back to my screen there. I'll come back to that later. But there are lots of activities. You go to education.ti.com, and then you go to activities, Math Inspired, and geometry. Now, one of the ones that I just wanted to point out quickly. So now we're going to continue in our quest for transformations. Well, some kids get a little bit bogged down if they have to construct everything. And the bottom line is, we want kids to be able to tell us what happens in a reflection or a translation or whatever we're doing. In the geometry, and this is also in the middle school, there are 4 things called bundles. And what the authors of this, they wanted this to be transformations in 15 seconds, meaning they didn't want the kids to necessarily have to do all of the construction. So I just wanted to show you this one very quickly, but I would encourage you to look at all of them. You know, dilations is sometimes kids struggle a little bit. These all look very similar. So, and again, remember, these all come with student activities, teacher notes, etc. So I'm going to jump over to the big page. All of the directions are basically up here. So this is right now saying, all right, if we have a scale factor of 2, and I want to dilate this triangle around point P, what's going to happen? Well, hopefully the kids would tell me what would happen with a scale factor of 2. So let's go ahead and click on this. And again, I'm just going to briefly. So if I click on that, there's my triangle. I can pick up one of these points, move it around. I can move this point around. Now, let's say that I want to go through and now compare what's going on with these lengths or the angles. So, but notice I didn't have to do the construction. So if I go to this little, and I can, yes, I can zoom in and zoom out. If I go to this little eyeball, I can choose which of the attributes that I want to study today. You know, maybe I just, you know, the kids are just starting off with this. Maybe I only want to look at angle measures and side lengths. But do notice all of the stuff that's here. It's just a wealth of information. So I'm going to go ahead and pick a couple of things. I will let you explore the rest of this. Now, this is again, in the activity, it starts to ask me questions. Well, right now it appears that my angle A and my angle A prime are the same. They're kind of ugly, but are they the same? Well, all I have to do is start dragging around here. Not a proof, but I can sure conjecture pretty quickly. And if I click on the next, remember I checked all of those things to show me. Then I could go through here and say, what's going on here? what kind of conjectures can I come up here? And then I could continue on and look at the ratios of the sides. There's the perimeters. There's the areas, which again are, mean nothing right now. But what's important is this. That 2 is showing up all the time. Oh no, what happened? Where'd the 4 come from? So again, all good discussions to have with kids. And you can change the scale factors. The default's a 2, but interesting to have a scale factor of a -1/4 or any of these. So once again, the construction was already done for us, and we can just do the discovery of all of the attributes. Okay, that was a quick run through of a little bit of geometry stuff. Any comments or questions? Have any of you, just put it in the chat real quick. Yeah. Have any of you ever used any of these bundles in your classes? Yes, no? Did you know about them or? Okay, Veronica says no. Again, I'd encourage you guys all to look at it and go to, again, education.ti.com. I believe Ruth put the website in there. They're really good. They really are. And I didn't show you even a quarter of what it can do. And like I said, there's a student worksheet that comes with it, and the kids can go through and discover all of this stuff. Great. It looks like most of you have not seen them. So again, I encourage you to do them. All right. That was geometry. That was one of our goals for tonight. The next one that we're going to look at, and again, this is only for our, sorry, let me go back here. Only for our software are doing images. All right, so again, you're going to have to just follow along with me if you're on your software, or if you're, this cannot be done on the handheld. So I wanted to make a couple of quick things here to talk about images. As we know, we're in a very visual world, and kids like it, we like it, and everything. So the more we can do with this, the more we can engage the kids. So I'm just in this document, it really doesn't mean a whole lot here. So I am going to add, now images can be put on several different kinds of pages. But for now, I'm going to add a graphs page. And once again, I'm going to hit escape. I'm going to go to menu. I'm going to put in that grid. You can decide if you want the grid or not. And now I want to insert an image. So the way that you insert the image on your software is to go up to insert and right down here to image. Now, depending on if you've done any of this before, your screen may not look like mine. You may have to do a search, or you may have to back out and go to this folder called TI-Nspire CX. When your software was installed, this is part of it. And in that folder, like I said, if you get out of this folder, you may have to find your way around. But there is a folder called images. And these are all the images that have come with the software itself. But before I pick one, what I want you to think about is the importance of using images, but we want to use these images to help develop math concepts. Not just because they're pretty or, things like that. So anyway, we want them to be, what kind of mathematics can I have them put in there? So what I'm going to do is I'm going to choose fence. Now, just by looking at this image in the chat, tell me, what are some math concepts that we might be able to explore with this image? Area of quadrilateral, good. Right triangles, good. Parallelogram, congruence, keep going, more and more. Guys are great. Isosceles triangles. Oh, good. Parallel lines, intersection, reflection. All right, perpendicular lines. So when the Nspire, keep them coming, vertical angles, great. When the Nspire first started being able to do images, again, before the Nspire came out, I was using some other geometric dynamic software, better known as Sketchpad. And we used to bring in images, and kids just really loved it because, again, especially if the image came from them. So yes, we have these images, but now you can go through and think about the mathematics that comes along with it. And boy, we had a whole bunch there in the chat. So again, depending on the age of your students and the subjects you're teaching. So now we could go through just like we did before. I could go to menu. I could go to geometry. I could go to and do some of those things that all of you were saying. What about parallel lines? Are these two things? I'm just picking those, no particular reason. But if I drop a line right here, and I put another one, very good here right now. All right, I'm off a little bit there. Forgive me. But somebody said parallel lines. So now the kids could go through and explore those things. And they seem to like to do that better than if you just gave them parallel lines and said, so now you could even, I don't know if anybody said this in the chat, and maybe it was implied, if these lines are truly parallel, which yes, we could go through now, even though my lines aren't great, we could go through and we could explore slope. And then we could say, all right, well, what about if this were a transversal? Or again, the amount of ideas here are just almost limitless as to the things that you can do. So think about, even though I put this in a graphs page, I could put it in a geometry page. So again, if I'm in a graphs page, I still have access to all of those great geometry things. So again, just the title of tonight's thing is just things my Nspire can do. So let's go for you algebra teachers. Yep, angles, great stuff. I'm going to add another graphs page. Again, I'm going to hit escape to put that equation away for a moment. I'm going to go to insert and an image. And I'm still in that folder. Another one that's quite popular is the fountain. Now, if you haven't seen this before, right? What could we do? Put it in the chat. What could we do with this image? Okay, quadratic functions, great. Maximums, yep. Equation, yep. So now this is, and again, keep it coming. This is where we could tie in. So now I'm kind of gone off into the algebra world a little bit. So if I press my tab key to get my function entry line back, or I could go over here to menu and get it back that way too. Well, now we can have discussions with kids about, and again, depending on the age group that you teach, So now we all know that x squared is not going to be right for this, but it's a discussion to have with kids. All right, what do I have to do to make that go upside down? What do I have to do to, do this? So I could either go back and change my equation and hit my up arrow and play around with this, or, of course, another strength of the Nspire is I can just manipulate this one. So I could flip this thing over, and I'm holding down my left mouse. I can translate it. And if I were patient enough, I could probably get fairly close to one of those fountains. Now, again, it's the job of the teacher to talk about this, and okay, what does this equation mean? Why is this a negative here? Why is it a negative a value? What is this 1.5, 4.7? And with kids, a lot of, the kind of mistakes that they make. They're thinking, well, why isn't this negative? And yeah, all of those kinds of things that we can do here that we already do in our classes. It's just here, we're putting it in the context of an image. And then some of the other things, of course, that you could do here is now talk about translations. Well, what do I have to do to this parabola to make it go over to this one or to this one? Or what happens if I change my coordinate system? So I can go out here to space a little bit and, sorry, not picking. All I did was hold down my left mouse. Yeah, multiple translations, absolutely. So now, this is a whole different ballgame now. Of course, this equation no longer fits because I've moved my origin. Or maybe I changed my window in one of the other ways. So there's just so much that can be done with images. So, again, I'm just kind of hitting the high points here tonight. Any other comments, questions? Do any of you have kids bring images and do anything with images? Because it's pretty easy. I mean, they could just take a picture on their phone, email it to you, and then you could use theirs. And again, it would be up to you and your students to try to figure out the mathematics. Great. So it's, and the kids just really take some ownership in it if it's their pictures. But once again, we want to make sure that, we're building in the mathematics behind it, which especially, on some of these is easy to do. And others, we have to talk about it a little bit more. So I would encourage you to do that. Any other comments, questions on images? Again, this is software only where we create them, but then I can send this document to my students, and they could go through. So let me delete this. I could send this even if I wanted to move my origin back, or I just am eyeballing that. But now I could send this to my students and they could go through and fit that equation or come up with that vertex or, again, explore in their geometry classes, explore this stuff by using the tools that we have. Okay, the other thing that I wanted to do tonight is a little bit with lists and spreadsheets. All right, so this you should be able to all do on the handheld. So if you're going along with me here, and what I'm going to do is I'm going to show you two things, but just give me a second here. So I'm going to press Control Doc, and I'm going to go to List and Spreadsheets. spreadsheet. This is called a list and spreadsheet because, first of all, I can deal with it like the list of the TI-84, but I can also do the spreadsheet notation. So you'll notice here that this is A1 where my cursor happens to be. But again, if I decide to name this list or do whatever, so there's lots of things that you can do with this. So this is like a little mini Excel. All right, so this equal is the formula row. And yes, there's a lot of stuff that you can do, which of course we're not going to be able to get to all tonight. Now, what I would like you to do, and I believe I already typed these in. So I'm going to give you a second here, not a second. I wanted them to be typed in so that I could talk possibly while you're typing. So I have two lists here. And the first one, and go all the way up to the top, the first one I call time in seconds, basically. Now, that underscore came from the key right next to the G. So if you wanted to put that in, you could. So I have some data here that possibly I've collected in some way or another that I'm hoping to see a relationship between the time that it took in seconds and the distance that something happened in meters. So why don't you take just a little bit of time and type those in. And if you make a mistake, no big deal. We'll fix it. I just thought I'd have it typed in so that you didn't necessarily have to watch me typing. And if you are typing along with me, maybe tell me when you got it, when you're done typing. And I don't care if you don't name the list the same as mine, doesn't matter. Okay, Mark's done. Okay. Hi, Carlines. All right, while the rest of you are finishing, again, just a few things, some of the nuts and bolts of list and spreadsheet and data. And if you teach a statistics class, there might be a whole lot more that you do with this. But remember, again, the title of this talk was just, some things that my Nspire can do. Nothing, real fancy or anything, but that's up to you to continue to explore. And I know we have some beginners and some not. So hopefully you can get something out of it. Okay, so we have just these 5 data points, not a lot. Multiple ways that I can graph this. All right. I mean, again, lots of different things that you can do with this. So as I said, this would be up to you to decide how you want to do it. So one way is I'm going to go to menu. No, I'm not. Let's do this first. I'm going to add a data and statistics page. This is not the only way. All right, so what happened here, and yours may look different than mine because part of it depends on where your cursor was. It's just kind of got these points all over the place. Notice that it says down here, click to add a variable, click to add a variable. So I'm going to go down to my, better known as the x-axis, click. And again, this is where we would have discussion with kids as to, which of these things do I want as the independent, dependent, domain and range, and all those other good discussions. So I'm going to put time on my x-axis, and it automatically makes a dot plot. Again, my data is pretty limited here. And then I'm going to either tab or click over here and put distance. So again, the discussions with kids would be, all right, what is this graph saying to you? Well, it's saying that the distance in meters depends on the time in seconds. And it's not a perfect linear model, but not bad. I mean, again, those are discussions that we could have with kids. But just to point out a couple of things that you could do. So I'm going to press my menu key. And notice that, of course, the menu changed because I'm in a different app. And if I go to, you may want to peruse some of these things. But if you go through, the one that I wanted to point out first is under Analyze. Sometimes I think it's good for kids to think about what this should look like. So I always like to start off with a movable line. And these, for those of you that have been around for a while, these are like the old days of us putting a piece of spaghetti on our data plots and trying to think about what this might look like. Now, this is the line I have right now. I could go through and drag it around a little bit. And I'm just changing the slope a little bit. So all I'm doing is holding my left mouse down and I'm going to say, okay, that, again, we could talk to the kids about what makes a good line of fit and all of those, if that's appropriate for your subject. But now really what I want to know is, given this movable line, what would be the distance if the time were 10? Now I could go back to my data and I could put it in there, but instead I'm going to add a calculator page. And if you now press the var key, you'll notice that that M1 for the movable line is there, or I could have typed it in. So I'm going to go M1, and I want to know, according to my movable line, what would be, if I were to do something for 10 seconds, what would be the distance? And according to mine, now yours might be different, according to mine, my distance in meters would be 12.6. All right, so let's go back now. And I am going to, just to not muck up the screen, I'm going to remove my movable line. Not bad, but I'm going to remove it for now. All right. In a lot of curriculum, of course, are the whole topic of regression. So let's do some regression. Go to menu. Again, Analyze. Regression. And we said before that it's fairly linear. But if you're in a class where, and again, think about the different kinds of linear here. We could also, if it were appropriate, talk about the median line, which possibly would be appropriate in a statistics class. I used to do median in my Algebra 2 and my Honors Algebra 2 classes. But again, those were things that you could talk about. So I'm going to choose the first one. And I happen to have my diagnostics on, which you again can get from your menu. So I can see how good of a fit it is. And once again, this might be a discussion with kids as to, if appropriate, what this stuff means. Again, if we talk about rate of change. Well, here, if I'm looking at 1.17 as my slope, and then equate that to the rate of change, etc. So very quickly, because I know we're about to run out of time. Oops, I don't want to do that, sorry. I'm going to go back to my calculator page, and I want to see how good I did with my movable line. Well, if I press the var key, yikes, all kinds of stuff there. Most of that came from when I did the regression. So I want to use the regression equation. Yeah, I could have typed that in too, but that's a lot of letters. And now I'm going to put in 10 again. Oops, missed. So we could have a discussion here. Now, one other thing, and then I'm going to turn this back to Ruth, that is kind of fun to look at if it's appropriate for your class, is to go to menu. And again, I'm going to go to analyze, and I'm going to look at the residuals. Now, I can either show the residual plot or the squares. So I'm going to show the residuals plot. Now, in statistics, we learned that if this is fairly scattered, that it's not making a pattern, it's a pretty decent line. Whereas, and again, that would be discussion with kids. Yes, it will be recorded. It is being recorded. But you could also talk about, again, if it were appropriate for your classroom, is to go to residuals. Whoops, I'm sorry. Went too fast there. And show, I could hide, again, hide things, show things. Again, all of the different things that I'm just going to hit escape out of that. But notice that here, the sum of the squares, not bad. We want that to be the smallest it can be. And you can hardly see those little squares. You see those little residual squares? Can't see them there because it's pretty perfect. Pretty perfect. I don't know if that's an expression, but you can barely see them there, those little squares. So lots of statistics to get into. So before I hand this back to Ruth, again, I would encourage you to go onto education.ti.com and go to activities, math inspired, go to statistics, and one of our favorites is one called scatterplot pulse rates, which again, you can get from bivariate data. And this goes through, and the data's already in here, which we know sometimes if kids type in data, mistakes are made. So there's quite a bit of data here too. And then we can have, again, all of those things about, well, what fits this? And again, I'm just flying through this, but lots of great activities there. All right, Ruth, you want to take it back?
Thank you, Judy. You have certainly given us a lot to think about. Yes, ma'am. All right. As we are viewing this, if you still have remaining questions, send them out to Judy in the chat. Remember, you can save the chat. As you're signing off, it'll give you an opportunity to save the chat. Now, it might depend on what device you're on, but you can save that chat. On mine, I look in File and Save, and I can save it. But that's because I have the entire console. But you have the chat available to you. All right, a webinar drawing. All right. Okay, so the winner receives complimentary registration to the virtual T-Cubed conference, the international conference that is going to be in July. To get tonight's winner, I used my TI-Nspire random number generator, had a list of all of the attendees who are present here tonight. I counted down, and the winner is, drum roll please, Gerald Oberg. Gerald Oberg. All right, I'll put that out in the chat. Congratulations, Gerald. And I see that you just sent me a chat. Yes, remarkable coincidence there. Random number generator counting down. Congratulations, Gerald. You'll be getting an email from a TIer that will give you information about that complimentary registration. Okay, so certificate of attendance for tonight's event. I'll put that link in the chat as well. That wasn't the chat. This one's the chat. All right. Okay. You'll also be getting an email with information about your certificate of attendance and documents for tonight's event. I'm going to put that in the chat in case you just can't wait that day or two to get the email with the information about the documents. So there's a link with that will let you download documents related to tonight's event. I'm also going to put in the chat the link to the recording of part 1 of this. All right. Had some people who were interested in that. So that's coming out to you in the chat. Oh, that wasn't a link. Let me see if I can do better.
In
Copy.
part 1, we did a lot of stuff with the calculator and the graphs app and a real world problem. And
All right. I obviously can't talk and type at the same time, but I will put a link to that. Let's see. Can I copy? Yes, there we go. Maybe I did it this time. Ta-da!
yay,
All right.
yay.
Education.ti.com under professional development webinars. This one is live. The other after this it'll be on demand. All right. So in the chat, you've gotten a link to part 1. You've gotten a link to the documents that you can download for tonight's session. You've gotten a link to the certificate of attendance. Lots of stuff going on there. All right. And that came out there. Just going to look up and down the chat again, see if we have any questions. I think we're good.
Okay.
Thank you so much, everybody.
Good
We'll keep the
night.
chat going for just a minute in case you need to copy it. We won't shut it off yet. Thanks, Judy. Thanks.